Hey guys, today I'd like to talk about existing standards related to remote drone ID technology and policies around it. The first standard is Consumer Technology Association CTA 2063. This standard describes drone serial number. It has three parts. First part is manufacturing code. Second part is land character, and third part is serial number itself. So here is example of serial number, manufacturing code ABCD, and serial number itself is drone 1, 2, 3, 4, 5, 6, 7, 8, 9, XY. And this serial number contains 15 characters, which is described as letter F. The second standard I'd like to talk today is ASTM International F3411. The scope of this standard is transmission and receiving broadcast remote ID, then receiving, processing, and displaying a network remote ID. And also it covers such aspect as intent-based operation. Before going to details of broadcast remote ID and network remote ID, I'd like to highlight important concept of them. Broadcast remote ID is based on 4 existing technologies: Bluetooth 4.5, Wi-Fi neighborhood aware network, and Wi-Fi beacon. Broadcasting is connectionless communication. Authentication and signature verification are optional for broadcast. Broadcast remote ID data is put on a link layer of TCP IP stack. There is no network information for broadcasting, no IP addresses. All broadcast remote ID information divided by messages, and messages are put directly in a frame payload. Network remote ID goes through internet only. Network remote ID concept includes intent-based pre-flight reporting. There are 2 key roles in network remote ID. The first role is network remote ID service provider, and the second role is network remote ID display provider. Network remote ID service providers remain in contact with unmanned aircraft during the flight, but supports interruptions. As for network display providers, they get information from network service providers, and network service providers actually are brokers for them. All communication between all participants in network remote ID must be encrypted and authenticated. The standard also provides a common data dictionary. What is it? These are fields which can be or must be included in remote ID information. There are currently 34 fields in list, and I just provide example of some of them. For instance, unmanned aircraft ID can be serial number, which I mentioned before, registration ID, or session ID. You can find more details going directly in the standard. Let's go into details about broadcast standard. As I mentioned before, standard describes 4 possible mechanisms for transmitting remote ID data. They are Bluetooth version 4, they call it Bluetooth Legacy, Bluetooth version 5, they call it Bluetooth long range, Wi-Fi neighborhood awareness network, Wi-Fi NAN, and Wi-Fi beacon. If you look at this transport mechanism, you will see an issue because each technology has its own capacity for transmitting payload. The minimum payload has Bluetooth legacy, Bluetooth 4, and it's able to transmit only 25 bytes of remote ID data in transmitting frame. So how can we put all remote ID data in 25 bytes? It's not possible, you understand that. So from this perspective, standard offers basic minimum message format, which contains 25 bytes. All information included in remote ID can be transmitted as a sequence of messages. So the standard allocates 4 bits to set up message type in message header. Message type 0, they call it basic ID message. It is a static message, which means it should be transmitted at least once per 3 seconds. And the length of basic ID message is 25 bytes. This message keeps information about remote ID, which can be serial number, session ID, or UTM ID. Message type 1. This is location vector message. It is dynamic one, so it means it should be transmitted at least once per second. It has length of 25 bytes and keep information about location, altitude, direction, and speed. Message type 2 is set for authentication message. This is static message. Here is the problem. Authentication message can keep message signature. A different standard has different length of message signature. It can be long enough, up to 225 bytes, and it's not possible to put all signature and existing 25 bytes. From this point, standard introduces message page. So signature can be split in 16 pages, and the receiver will assemble a signature having all these pages together. Type number 3. This is a static message. They call it self-ID message. The length of it is 25 bytes. The purpose of this message is to put information declared by pilot. It can be mission ID or pilot name or whatever you want. Type number 4, they call it system message. This is static message, 25 bytes length. Type number 5 is static message, 25 bytes. It contains operator ID, which is required by several regulations in different countries. Finally, the standard introduces message type 15. They call it message pack, and it is dynamic message. What's the purpose of message pack? As I mentioned before, Bluetooth 5, Wi-Fi NAN, and Wi-Fi beacon has capacity of transmitted up to 225 bytes in one frame. From this perspective, it's not clever to put just one message which has 25 bytes length. Message pack combines other message types in a single long message and transmitted once in one frame. The receiver part should parse this long message into a set of separate messages. In this slide, I put summary information about frame content in different transport mechanisms. So Bluetooth 4 keeps open drone message, the length of it 25 bytes, together with protocol-specific fields, and audit open drone ID data is in advertising beacon messages. For Bluetooth 5, standard recommends using message pack length up to 225 bytes together with protocol-specific fields. And audit data is supposed to put in advertising secondary pack. For Wi-Fi none, they recommend using a message pack message type, which has length up to 225 bytes. And they put this information together with protocol-specific fields. Audit data should be put in service info field. For Wi-Fi beacon, they recommend to use message pack again. The length of it is up to 250 bytes together with protocol-specific fields. And audit data should be set in service set ID, beacon frame, and included in vendor-specific tag. Let's switch to network remote ID. Standard provides a concept of 4 basic interfaces between participants of network remote ID operations. These interfaces are unmanned aircraft system to network read service provider, operator of intent-based participant to net read service provider, net read service provider to net read display provider, and net read display provider to display client. I put short information about each interface on the following slide. The most interesting part is communication between network service provider and network read display provider. The standard provides architectural view of communication between these actors. As you can see, basic communication contains 4 steps. On the first step, network service provider, which keeps information about real-time flights, make this information discoverable in discovery and synchronization service. On the second step, whenever client wants to have information in a particular geographic area, it requests display service provider to get this information. Display service provider interacts with discovery and synchronization service, and in response, a client is able to see basic information about flight in particular area. Later on, display service provider can get additional information, get details about particular flight from service provider on a step 3. And on a step 4, whenever service provider has updated real-time data about flights in particular area, it can notify display service provider about change in operations. So client will see real-time picture in his application. This is all information I was going to give you about CTA and ASTM standards. If you want to have more details, you can find link for those standards in description of this video. Thank you for watching this video. Have a nice day.